All right, so this problem says, it's called Outlawing Cigarettes, and it says Harper's Index claims that at most 23% of people in the United States are in favor of outlawing cigarettes. All right, so suppose you decide to test this claim and sample 200 people. So if 27% of those you poll are in favor of outlawing cigarettes, is this enough evidence to doubt the claim by Harper's? All right, all right, so let's see, what kind of problem is this? It's asking us to test some kind of claim, so it's likely to be what kind of test?
A hypothesis.
Yeah, whenever you're going to test a claim, to either reject it or to accept, it's a hypothesis test. So for a hypothesis test, you have to look at a couple things. You have to find the null hypothesis and then also the alternative hypothesis as well. And once you have those set up, then you can go ahead and calculate a z-value, which is a test statistic, and see which of those hypotheses you believe. All right, so in this one, it says that Harper's Index, which I guess is a magazine, claims that at most 23% of all people in the United States are in favor of outlawing cigarettes. So the population proportion, which is a thing I want to test here, has got to go into H0, the null hypothesis. So in this case, that value is what?
That would be 0.23.
Yeah, it's this 23%, because this is the 23% that Harper's is making the claim, or this is the amount that Harper's is making the claim about. So that's going to be our theta, and that corresponds to the population proportion that we want to test. Okay, so let's make theta equal to 0.23. Now, what we want to test here with our sample, so our sample is 200. Let's write that down. So that's the sample size. So n is equal to 200. So let's write down HA down here. All right, so when you test for a hypothesis test, you either test whether theta is different from this value up here, whether theta is bigger than this value up here, or whether theta is less than this value up here. So which thing are we testing here?
If it's greater than.
Yeah, because we want to see our sample is over at 27% here. And Harper's is claiming that at most 23% are in favor of outlawing. So we want to see the alternative would be finding out if more than 23% are in favor of outlawing. So we want to test theta is bigger than 0.23 there for the alternative. All right, good. Now, what do we do? How do we set this up?
Oh, so from here we would put it in the...
Let's draw a picture of it first.
Oh, okay.
Okay, let's draw a picture of it first. So over here, let's see, let's draw the p-hat distribution. We're looking at sample proportions, right? So let's draw the p-hat distribution. And in the middle of the p-hat distribution, what do we put?
0.23.
Yeah, that's that theta value, right? So this is going to be the 0.23. This is the thing we want to test. Okay. And our calculations that we're going to do are always change things that are in the p-hat distribution and put them into a z picture over here, a z-graph. So let's write z over here. So we're going to change things into z-scores when we get started here in a minute. And the thing that corresponds to 0.23 over here as a z-score is what?
It would be 0.
Yeah, it's the thing that's 0 here. So this is the standard normal curve over here, and this is the p-hat distribution over here. All right, so this is the standard normal, and this is the p-hat distribution over here. All right, and most of our sample proportions here are close to this population proportion, 0.23, but you can also get samples that are fairly far apart if you're unlucky. All right, so let's see. Now, what do we want to test? What else do we need to put in here in our picture? Where does this 27% go?
27%.
So that's not the population proportion we're testing is 23%, right? That's just 0.23. Right. But what does this 27% down here represent? That's got to be the thing that comes from the test statistic, right?
Oh, so is that what we're dividing?
Yeah, no, that's going to be our p-hat that we test. Okay. That's going to be our test statistic. Now, 27% is where in relation to this 0.23? Is to the right or to the left of it?
To the right.
Yeah, to the right. So let's draw it over here. So this is 0.27 right here. All right, so if we're going to be testing this alternative hypothesis where theta is bigger than 0.23, then what I want to do is get this area that's over to the right of 0.27 there, right? That's a right tail. And then this area right here is called a p-value. All right, so we're looking for this area right here, and that'll be the p-value. And that'll tell me the size of that p-value will tell me whether or not I believe this null hypothesis up here. All right, so what do we got to do? We got to get this 0.27 and change it into a z-score. How do we do that?
So we want to do z equals the data value minus the mean.
Okay, wait a minute. So data minus mean. Good, good, good.
Over the standard
That's right. Over the standard deviation. Okay. Now, the data in this case is what? Which value are we looking at here?
0.227.
Yeah, that's right. So 0.27 goes right here, and then the mean, that's the value in the middle here. That's 0.23. And the standard deviation, how do we get it?
Oh, we have to...
we got to compute it, right?
Yeah, we have to put it in.
Okay, so let's put it down here. Okay, what's the formula? Do you remember what the formula is?
It's the mean.
Yeah, it's this mean that we're testing. So it's 0.23
times 1 minus 0.23.
Yeah, that's right.
Divided by the n, which is 200.
Yeah, 200. Good. Okay. So with a calculator, are you ready? Yep. What we got to compute is, here, I'll give it to you. It's 0.23 times 0.77 divide by 200, and then take a square root of that. What'd you get?
0.0297.
0.0297. Okay, we'll put that down here. 0.297. All right, so now take 0.27 minus 0.23. What do you get?
0.04.
Divide that by 0.0297.
1.346.
1.34. Okay, so 1.346. Okay, good. All right, so that's our z value that's over here, right? It's over here to the right. So this is 1.3. Let's round it off, 1.35. And the area we're after is to the right of that, right? And that's going to be our p-value. So that's right. P is going to be that area. How do we compute that area?
Oh, the way we do that greater than is 1 minus the table lookup.
That's right. So it's a tail. And remember, our table can only do the lookup from the left-hand side up to this value right here. So in order to get the right-hand tail over here, we got to take 1.0 minus the table lookup. And then we're going to have to do a table lookup of 1.35, right? All right. So 1.34. So look up the z value 1.35 and tell me what you get. .9115. 9115. Okay, good. So now take 1. Ready with the calculator again? 1 minus 0.9115.
Negative 0.9115.
Can't be right. Try it again. 1 minus 0.9115. Is that right?
Oh, 0.0885.
0.08. That sounds better. Okay, so 0.0885.
85.
Okay, so so our p-value is about 0.08, like that, or 0.09, and now we have to look and see based on the size of the p-value what that leads us to conclude about h0. Okay. So do we have that table of conclusions for that?
So it would be here. So 0.05 to 1.
Yeah, so it's between
there's just some evidence.
Some evidence against the null hypothesis, right? Okay, so this is some evidence against H0. All right, so good. So that tells us this sample that we got, the 27%, is some evidence against H0, but certainly not strong evidence against H0, right? Okay, good.